290 kelvins, not bad. But it's maybe a little too cold, but it's not terribly cold, right? Not as cold as Pluto, but its mass is too small for it to retain anything more than a weak carbon dioxide atmosphere. And then we come to Venus, my favorite. It's too hot. It has a temperature of 740 Kelvin. That's so high, so much, so hot, but it's massive enough to retain a thick carbon dioxide atmosphere. So see how I was mentioning earlier about the carbon dioxide, too much carbon dioxide in the Venusian atmosphere. I love that word, Venusian. Too much carbon dioxide in the Venusian atmosphere, but it does have a thick atmosphere. So it's almost like Venus was so close. It has an atmosphere, which is actually very helpful, but it's too hot because it's closer to the sun. And that heat also doesn't let it have oceans. And so those oceans, the absence of those oceans makes it so that it has too much carbon dioxide because the water is not absorbing it and turning it into limestone like we do on our excellent planet Earth. So Venus, too hot. Plus, I think Venus is too hot too. Like, it's almost like you can make yourself maybe warmer, but I don't know if you can make yourself cooler on such an extreme sort of environment, right? In such an extreme sort of environment, like the Venusian surface being 740 Kelvin, that's quite a bit high, you know, and also the very thick poisonous atmosphere, which is mainly carbon dioxide, which is kind of bad for us. But I mean, there could be other things that like that. I don't know. The Earth is warmer than Mars, but it is massive enough to have retained a dense carbon dioxide atmosphere initially. So we also did that. This evolved into a thinner nitrogen and oxygen atmosphere because of the presence of liquid water, like I was saying, which removed the carbon dioxide, and plant life, which added the oxygen. So we have oceans and plants to thank when it comes to our own home planet being habitable and good for us, where we can breathe and stuff. Who do you think created the pyramids? Doro did, apparently. He did. So anyway, the Earth is warmer than Mars, but because it has liquid water, it's both massive enough to have retained a dense carbon dioxide atmosphere initially, but this evolved into nitrogen and oxygen atmosphere because of the presence of liquid water, which turned the carbon dioxide into limestone, like I was saying. And then plant life also helped to convert carbon dioxide to oxygen. So we have oceans and plants to thank, indeed. Ooh, can we get 20 likes? This channel used to be about the moon. Not really. It can be again. We actually just talked about the moon. You missed it. We did land on the moon. Has missed the moon point. Oh yeah, can you please like the live? Thank you so much. Could we get 20 likes? So, that was about the Earth. Next is Jupiter, or sorry, the Jovian planets. The Jovian planets are sufficiently cold and massive to retain thick atmospheres of hydrogen and helium. So it's very interesting when you go over to the Jovian planets, Jupiter, Saturn, Uranus, and Neptune. All of those are, of course, extremely massive compared to the terrestrial planets. So all of them are sufficiently cold. In fact, they will have stuff that will condensate at lower temperatures, right? Because they're